Good morning, everybody. I am Dr. Poonam Dikshit, working as an assistant professor in, UIT CSJMU Kanpur. The speaker of this session is Dr. Chandranath Adak. He is a visiting fellow at FEIT University of Technology, Sydney, and an assistant professor at the Department of Computer Science and Engineering, IIT Patna. Before that, he was a researcher at CIBCI Center, University of Technology, Sydney, UTS. He also obtained his PhD degree from UTS. I am quite sure that beginners are really going to benefit from this session. Now, sir, I request to you kindly share your valuable knowledge to the everyone.
Okay, so we'll come again. So we'll perform this hands-on session on basic example of convolutional neural network, and for this I will use Google Colab. Okay, so let me share my screen. So if we type over here Google Colab, okay, so go to this link and say just a minute. So obviously need to have one Google account for this. So new notebook, and framework I will use here TensorFlow, and programming language obviously will be Python. So for that, because I am using the TensorFlow, obviously I need to import the TensorFlow. So how I will import the TensorFlow? And Python is basically a very simple language, and the will import. I will write this as well. Okay, import tensor. But TensorFlow, this spelling is bigger. So it has like 10 characters. So multiple times I don't want to write it as a TensorFlow. So in short, I am renaming it as a import TensorFlow as TF. Then you can run, and this we call, wherever I am writing this, we call as a cell. So this cell, to run this cell, you can click over here, or you can press Control Enter at the same time. Okay. So it is, and here you can see it is trying to connect. So that's why it is taking some time initially. So it is initializing. So here, so now it is showing as connected. And how much RAM and disk space I have been allocated, you can see over here. So I have been allocated 12.68 GB, and hard disk or disk space I have been allocated 107.70. And as I have already told you, the image will see as a matrix. So for that, there is few already libraries are there. I will use those. Okay. So here I will use NumPy, import NumPy. The same thing, NumPy also I will write it as a NumPy, and few other libraries I may use. Let me import. So say for plotting few diagrams, say matplotlib.py plot. So if you wait sometime, so it will also show you like the spelling or this thing. That's PLT. So then again I'm running this. And in the TensorFlow, actually previously the Keras was different framework. Now the inside the TensorFlow we can use the Keras. So in the Keras there are multiple data sets. So one famous data set is a CIFAR data set. So you want to learn more about the CIFAR data set. So here is a website. So Toronto University's data set. So in this website you can learn what is the data set. Okay. So we'll work on CIFAR 10 data set. So in that data set we have say 10 different classes. So class 1 is say airplane, then class 2 is automobile, then bird, cat, deer, up to this truck. Okay. So how many images are there you can also see. So 10 type of objects are there or 10 types of images are there. So that's why. So our objective is we will train a model, and suppose one unknown image has come, so our model can predict easily what is the image. So the easy way to think of, say you are teaching a child, say a baby, so you have shown him some images, say cat, dog, horse, this airplane. So after a certain time you are checking, okay, this person can easily understand these images or not. Okay. But sometimes you may think of, okay, these are very childish examples. So, okay, our human brain can do this. So why we need to like, what is the utility? So if I say, okay, we can use this for say biometrics purpose, for say face recognition. So suppose in your college there is a smart door. So that smart door will only open when one person's image has been already registered. So there are say in your institute, suppose there are say 2,000 persons are there. So obviously that will be say 2,000 class for face recognition. So this person, okay, this is some person X, this is the student of our institute. So open the door. So the door will be open. So there are many applications. Say in the banking sector. So in banks, say there are say lakhs of customers. So if you want to build a say signature verification system or signature recognition system, so it can easily recognize or verify that signature. Okay. For those domain, you can also the same model you can use in various applications by changing the data sets. Okay. So here and also say the OCR, optical character recognition. So suppose there are say one handwritten page or the printed page is there, you need to understand which character it is written. Okay. For say English language, we have only say 26 upper letter, 26 lower letter, and say 10 numerals. But suppose in our say some Indian language, say for example say Hindi, we have say many say characters. When we are writing some compound or conjunct character, and in Chinese say there are say 10,000 characters. So based on the application, the model may change little bit, and obviously the training set we need to train the model accordingly. So more details of this data set you can find here. So this is CIFAR 10, and there is another data set CIFAR 100. So there are 100 classes are there. So some examples are here, you can see. Okay, so let's jump into this one. The problem statement is clear with everyone, what we are trying to do. Any doubt? So for that, what we'll do, in the CIFAR 10 data set, already there are train and test data are already there, so we will use that one. For that, let's write 10 images and train labels. So here the label I forgot to tell you. Suppose you have some image just try to think of the early beginning of this class. So we have some images, either it is orange, either it is apple. So this orange and apple, this we call as a label. So this means every image has some label or in the training data. So this is we call as a supervised learning. So already we have some label data. Okay. I'm not going into details of other types unsupervised. So let's stick with the supervised learning where the images have some labels. And similarly, test images. Let me copy this paste. What I am doing, I am extracting the train images with their labels and some test images with their labels. TF, and inside TF we have keras dot data sets dot cipher10 dot load data. So if you wait a fraction of second, it will automatically come. You will just press enter. And after that, open and close parentheses. I prefer to write like one command in a cell. So you can write multiple commands in a particular cell, because if there is some spelling error, so if you write a multiple lines, so it will be proper. It's up to you. Any doubt? If you don't have any question, please mute yourself. So you can check the shape of the images. So train images dot shape. We have 50,000 training images and each of size 32 cross 32 cross 3. So why it is 3? Anyone can tell? Aditya, would you please mute yourself if you don't have any question? Okay, so why this is 3 over here, 32 cross 32 cross 3? Because it is RGB image. So RGB 3 channels are there. Okay. And let us check like how many test images we have. So it's test. So we have 50,000 train images and 10,000 test images. Everything having size of say 32 cross 32 cross 3. Okay. Now we need to define the class names. Okay. Anyone is asking any question? I did not understand. Are you trying to say something? To everyone? Hello.
Yes, sir, please continue.
Sir.
Voice clear नहीं आ रही sir.
You can't listen, right? Could you please type like what's the issue in the chat box?
Sir, clear, sir.
Okay. So class name. Sometimes this screen may freeze, maybe due to the connectivity of with the Colab, maybe. So class names. From where we will get these class names? So class names we will get from here. This CIFAR here, CIFAR 10 dataset. So first one is airplane, then automobile, bird, cat, deer, dog, frog, horse. So you need to copy this thing. Okay. So I am copying it. Then I paste. So here inside this third bracket, I will paste. I am pasting this. So then From the data set, we will know this thing. You see this code? Okay, so I am done with this class, but here we need to put this within a inverted comma. Okay. This is a manual task. Yeah, I am done. So now what we will do, we will normalize the images. So how we will normalize? Say one image value is from 0 to 255, say pixel value. So we will normalize or divide it with the 255. So 10 images equal to 10 images divided by 255 and test images similarly. Now let's take few images like how it looks like. So for that, whatever I have import previously, the plot from matplotlib. So plot dot figure. So plot dot I am show. I will show only the say first image. Say plain images the zeroth index one. Okay. And so if we show this, if you see this, okay, this some images are there, but it looks quite hazy because it's the image size is only 32 cross 32. So we need to know like what is the class name of this image. Okay, so for that we need to see the name of this class. Okay, so for this, in the class name we have all these things information. So class names, then labels. Okay, you can see here the name frog is coming. So this is an image of a frog. Okay. So similarly, you can plot multiple images. So for say plot figure size. I am reducing for plotting. I am reducing the size. Okay. So for I in range 25. Dot say plot say each row say 5 images and and plot. Then images live and plot dot labels. Here, let me copy from here. level 5. Let's check. It is running. So here it is. Oh, there is a spelling mistake. It will be X level. Okay. Okay. So now you can see this. Okay, this is an image of deer, cat, frog, but in between it is not showing. So for that reason, we need to like delete this 0 to 32, this size. It is the size of this image it is showing. So for that we can just simply write sticks on this dot y sticks. Now it will show perfectly. Okay, now you can see it is a frog image. So this is the first one we saw earlier. Truck. This one is truck, deer, automobile. Okay, few examples we have already seen. Okay. Then quickly let's build the model. Okay. So that is our main task. Okay. So how we will build the model? So from TensorFlow dot eras, say import layers. Okay. So now I will build the model. It will be sequential model. So df dot eras sequential first bracket, then within this third bracket, so what I will write, say at first I am adding say one convolutional layer. Okay, say layers dot here you can see conv2d is coming. So I am using conv2d. Then I will use the number of filters. So in theory class, we have used the number of filters 2. Now I am using the 32 number of filters, and kernel size I am using 3 cross 3. Okay, so here how we will write 3, 3. And activation function, so as I mentioned, like linearity is not always sufficient, so we need to add some non-linearity activation function. So here I will use activation, ReLU activation function. The mathematical formulation of ReLU you can check by yourself. I'm not going that detail. And input shape, what is the input shape we have? The image input side here, but we have already checked 32, into 3. So we'll copy this thing. Input shape equal to this. Okay. So perhaps you remember we have used some padding concepts, say same padding or valid padding. So here I will use same padding. Okay. Then next layer. So after one convolution layer, let us use max pooling. Okay. So it is max pooling 2D. And 2 cross 2, as in the theory class we have used, I am using that one. So after that, again I will use this convolutional layer. So I'm just copying this. One convolution, then another max pooling, then again another convolution. So here I will use this 64. So this is up to you. So this is the model designing. This we call as a hyperparameter. So this whether it will be 32 or 64, you will use 3x3 kernel size. What you want to use. This is your hyperparameter. But and for in our deep learning technique, we want to learn the learning parameter. So there is some difference between hyperparameter and learning parameter. Learning parameter will be inside this 3,3 is your hyperparameter, the size. But inside that, say you have that 9 values that you want to learn, that is your learning parameter. Okay. So 64 so you can write it as a kernel size equal to this, or you can also, there are various syntax, so you can write also in this way. So after that, here also I am using say ReLU, and here I don't need to use say input say. Okay. And padding, previously I used same, now I am using say valid. Okay. So by default it is valid. So whenever you will not use anything, it will be valid by default. Okay. For the same, you need to explicitly mention. So again, I will use this max pooling layer. And then what I will do, I will, so by default valid. Okay. If I just delete this thing, this will also work as a valid. Okay. No need to write, but let's write. So now this max pooling, what I will do, I will flatten this layer. So layers dot flatten then layers dot dense 128 comma say activation equal to ReLU. Okay. And lastly, layers dot dense. So how many classes we have? Anyone?
10 classes, sir.
Yes, we have 10 classes. So that's why I'm writing 10 over here. And here also we are using activation function as softmax, as we mentioned in the theory class. In the last layer, we will use softmax. So let's run this thing. If there is no spelling mistake, it will be fine. So now, what we need to check? We need to check the model summary. So in the model summary, here you can simply check. Okay, at first so what we were calculating, so n plus 2p minus f divided by s plus 1 using that formula. So inside that everything has been written. So after that 32 cross 32, that one you are getting, okay, this one 16 cross 16. Why it is 32? Can anyone say why it is a 32 cross 32 again 32? Because I have used there 32 number of filters. Okay. And here I have used 64 number of filters. So here it is coming 64. And after the max pooling operation, the size of this matrix reduces to half, but the number of channels, it is remaining same, 32. So similarly, you can see over here, the size has been reduced to half, but the number of channels is same. So after that, if we calculate 7 into 7 into 64, you will get 3136 number of neurons. So that is coming over here. Okay. And we have used here one dense layer of 128 neurons. So another hidden layer. So that's why after that, it is fully connected with 128. And again, we have because it is 10 class classification, we have used 10 nodes, and it is also fully connected with the previous 128. So overall, we have trainable parameters is this 422,218, 4,22,218. So this is a huge number of parameters. Okay, so we are thankful to Google Colab. They are giving us this platform to freely train our model. Okay. But in the early days, like 10-20 years back, it was not that easy. Okay. So here in this run, yeah, any question? Anyone is asking?
Sir, sorry to interrupt. I have one
Yeah.
question. So in parameter column, so some places I see 0, right, against
Yes.
max pooling
Yes.
and yeah.
So
So
this parameter, yeah, I got you. So this is actually the learning parameters. Okay. So in the convolutional parameter, we have the kernel. So we are learning only the parameters inside the kernel. But in the max pooling layer, we don't have any learning parameter. That's why it is showing us a 0. Okay.
okay. Thank you.
So overall, if we calculate it is. So this is actually a good question for interview, that they will also ask you, like they have given say 3-4 convolution layer and 3-4 max pooling layer. So how many like learning layers are there? So only you need to count the convolution layer, and that will be your learning layers. Okay, not all the layers. And sometimes like okay, sometimes if it, so sometimes people may ask like how many layers it has. So like some say newbie, he or she can think of okay, 1 layer, 2 layer, 3 layer, 4, 5, 6, 7. So these many layers. Actually, that is not correct. Okay, we need to count. So it depends on the notion. Some books are say okay, you need to count this max pool layer as well, but preferably like most widely used notion is that you should compute the learnable layer. So this is the learnable layer, this is the learnable, this is the learnable. Okay, so these layers you need to check. Okay, and obviously one layer is the input layer that you have the image. Okay. So, and in some papers you have seen okay, some drawings, some diagrams are there. So they have beautifully drawn the diagram so that easily we can understand. But here there are some codes you can easily draw this diagram or plot that diagram, your model diagram. Okay. pf.keras.util. This is just for your presentation or your say paper writing. Okay. Not otherwise. Model 25 equal to. I am saving this image. Model underscore plot in PNG mode. I am saving. So steps through. So it will draw this diagram in a beautiful way. Okay, you don't need to like draw this. Okay, so you can just from here you can just here you see model underscore plot dot png. You can download this image and you can paste in your presentation or in your paper. Now we need to so our model is ready. So we need to compile our model. So here for the there are different type of function I have mentioned. One is activation function, one is loss function, and another one is the performance measure. How we are performing the measure. So here optimizer I am using Adam. Okay. So the Adam is not possible to tell you within 5-10 minutes. So okay, keep it as it is. But if you are interested, you can learn or email me. pf.keras.losses. So which loss function we should use over here? I have already told. So because it is multi-class classification, or more than 2 classes are there, 10 classes, so we will use cross entropy loss. So here one specific name is here, sparse categorical cross entropy. So it is here sparse categorical cross entropy, and few syntax are here and logics. And if you wait few times, it will show you the details, like, and the syntax details over here. So truly you don't need to remember all the syntax. And the performance metrics or the performance measure, how we will show, we will use the accuracy. So that means we will use the metrics accuracy. Okay. Let us compile. It has been done, compiled. So now we will run our model or train our model. So training, this may take some time. Equal to model dot fit here we need to pass train images, then labels, number of epochs means like how much time you need to train your model, retrain your model. So one forward connection, then back progression, then again forward. So how many times you need to retrain your model. So ideally you should run based on the data set. So for this case we should run say around at least say 50 times, but due to the shortage of time I am running only say for 2 epochs, but you should run at least say 50 times. You can check the curve whether it is stable or not. Okay. So validation, here I have not taken the validation data set separately. For the validation data, I am simply using the test images, whatever. But in real-time scenario, you should have some separate validation data, and the test data should come from the client side, from outside world. So it will take a few minutes. Let's check. So it is showing okay. You can see like 901 out of 1563. Okay. So if you train little longer or number of epochs you can increase, so maybe you will get some better accuracy. So now I am running only for 2 epochs, so maybe my model accuracy may be 50 or 60%. So that will be too much bad. Okay, you can check over here. Okay, my accuracy is now say 45%. But if we, and if anyone wants this code, like just email me, I will share this. So you can change this epoch value and train by yourself. Okay, without waiting, let me write the later parts. Okay. So here is the test loss, test accuracy, model dot evaluate test images, test. One epoch has been done. We have got the validation accuracy around 60%. Okay. So this is not good. Okay. You can print the accuracy. Say. So at first, here you can see this one accuracy 0.5038. This is our training accuracy, and validation accuracy is 60.81. So now we are saying, okay, this validation accuracy is because on the test data set. So this is our actual model accuracy. We will not in the paper we will not write the training accuracy. We write this validation accuracy or the training. Okay, we got this 64.26% accuracy. So we can
Sir, I have one more question. What does
Hmm.
this loss represent? Like we have loss and validation loss.
Yeah, loss is here the sparse categorical cross entropy loss. So here if we go just a minute. Dimension somewhere. Yeah. So here in this loss there are some formulas. So here 1 by n minus of 1 by n sum over yi log yi hat. So I hat is actually your predicted value. What the value you are predicting. This log over this into the actual class. So some numeric value you will get, and that we are actually we are showing. So in the ideal case, our loss will be 0, so no loss. But here, if we see, we have say this loss, we have say 1 point something.
But sir, my question is like, for example, accuracy. So from accuracy, we understand, okay, how good our model is. Maybe out of 100, it is correctly representing 64 images, let's say. So in that context, what does loss means? What is the significance?
Yes. It will take some time to explain. Okay. Let me try to explain in a short order. Okay. So this is your learning parameters W. Okay. And this loss is a function of this learning parameter. So we want to optimize this loss. So this ideally this curve will maybe look like this. So our target is to reach this global minima. Okay. So every time in global minima, our target is to reach. But it may so happen that this curve may look like this. So your function may be stuck over here, local minima. Okay. So this LW is actually L is a function of your y and y hat, and this y hat is the predicted value, means like what you are predicting, and this is your actual. And because this y hat is the function of this w, so overall we are saying, okay, this is some function of this for learning parameters. So this loss is for the model to understand, okay, it will further optimize or not. But accuracy is for us that, okay, how much accuracy we are getting. Clear?
Yes, thank you.
Okay. So accuracy, there will print the test accuracy. Let's see. Okay, we are getting the accuracy here 64.259. So this is actually this one. So in a better way, I am just printing. Okay, so now the main task that so you will say that example, you will show a child one image and ask him, okay, what is this image? So similarly, we will show our model an image that and asks, okay, what is this image is about? Okay, so for that prediction, so I am predicting all the things at a time. So then it will be easier to show you. Predict test images Now, say, now I will plot the test images. I am so test images. Say ith image. So let's take I equal to 1. Sometimes I will get misclassification because our accuracy is only 64%. So if you train elongatedly, train little longer, you may get say maybe you will get say 70 or 80% accuracy. But please don't expect that our this model with everything it will correctly classify. But still it will work little better because 64 is also okay, like np dot argmax predictions I. So okay, so you can like with your human eye, you can little bit understand. Okay, this is a sheep image. So our model is correctly classify this as a sheep. So now check like other few other images. So I equal to 5, say 5th images. This is showing as a frog. Maybe I don't know what it is actually. Okay. Now say 0 to 1. Okay, it is also say showing okay. Okay. So what we can do, one thing I can do. In the actual, so I can print the class names also here. Let's see. Class name. Test dot labels. It is actually cat and showing us as a cat. Okay. So now I equal to 10. So it, I don't know, like somehow whatever image I am taking, it is showing correctly, but there should be some mixed classification. Yeah, here the actual class level is bird, but our model is showing it as a deer. Okay, that means for this image our model has misclassified. Okay, the reason, this is one of the hyperparameters, a number of epochs. If you increase say 50 or 100, then maybe you will get some better result. And now a few little more things for presenting. So suppose you need to present to your boss or in a paper. So for that reason you need to plot. So how you will plot? So history I have already stored over here. History dot accuracy common level accuracy and here validation accuracy. And plot in the x-axis, I will plot the say number of epoch, and in the y-axis, we will plot the accuracy. Plot legend. So in the box it will show whatever we are plotting. Then we are done. Some mistake accuracy. So here this one bracket here, inverted comma space. So you can see in the 0th epoch this accuracy and 1. So if we increase the number of epochs is 0 to 50, you can see some good curves, okay, because we have already taken say 2 epochs, so that's why you are getting some sort of just straight line. Okay, this is number 1. So another code I have already written for you. Quickly I will show. So this is already the model we have built up. So on that basis I have shown you. But suppose one dataset you have built up. So for how you will do that? So I have already written the code over here. So for that reason, can you see this another tab, everyone? Okay. So here the simple code is from Google Colab import drive. So you need to have one Google Drive where you will upload all the data. Okay. So after that you will write say okay from Google Colab import drive and drive.mount. So after that if you run, so it maybe it will ask for login into your account. I have already logged in, so that's why it is not asking me again. So then your Google Drive will come over here. So if we refresh over here in left hand side, okay, in this Google Drive you can see all the data set, all the things you have in your Google Drive you can get. Okay, and here I have this glaucoma dataset. So it has a binary classification task. So you are given one eye image. So you need to identify whether the person has glaucoma or not, or this eye has glaucoma or not. Similarly, similar example in these days you have seen some chest X-ray images are there. You need to identify whether this X-ray is of a COVID patient or not. Okay. COVID versus non-COVID. Similarly, glaucoma versus non-glaucoma. Okay. So you can check over here. So I am just okay. Some error I am getting. Just a minute. Let me check. Okay. Just a minute. Trying to get the identity transparent currently. Actually, it is not connecting. Okay. So this the previous one is clear with everyone. So I am stopping that one. So maybe some free space will I can get that. So again, you will import all these things, and here similarly we have built a quite similar model like sequential, then one convolution layer, another max pool, then convolution max pool. So 3 convolution followed by 3 max pool operation. Then we have used flatten and one dense layer and another say sigmoid layer. Okay. just yeah. So I have already done this thing, so I can quickly show you. Okay. So after that, you have some dense layer because it is binary classification. You can use say 2 over here, or one thing you can do, you can use say one node, and after that you can keep a checking. Okay, if it is greater than say 1. Sorry, greater than 0.5, it is a glaucoma, or less than 0.5, it is non-glaucoma. You can also do in this one. And again, I have already plotted this thing diagram. And here, so in this data set, if you see the left hand side, okay, there is test and train folder. So in the train folder, we have 2 subfolders. That is one for glaucoma and another one is non-glaucoma. So here also I have divided this. So train G directory means for glaucoma, train NG for non-glaucoma. Similarly for test G for glaucoma, test NG for non-glaucoma. So here, so some import I have done, and here the loss I am using the binary cross entropy because it is a binary classification. So this line I have commented. So here we are because it is our data set from this Google Drive. So we need to generate image data generate we have used and rescale the image using 1/255. Okay. So similarly, we have generated the train data set and for the validation data set. But in the previous example, what I have shown, it is already in the Keras. We have the data set. We don't have to build this type of steps. Okay. So after that, okay, it is so here actually what we will do. Okay, just a minute. Actually, what I have done over say here 1. So after that, what we will do, we will feed this model using model.fit and use the train and validation data set. And after that, and we have used the class name. So one is for glaucoma and another is for non-glaucoma. Okay. So if so already this step was yeah. So after that, we will feed the model and store all the details in the history. And after that, there is not wget means like there is a now we are testing from a real data set. Okay. So in this website, you have one image. Okay. Here we have, this is of a image. So I inside image. So exact medical term I forget. So some test images are there from this website. So if we pass this using say not wget, so it will store this image, and here again we have to import this from PIL. Okay. From PIL on library, we need to import this image. So we will feed this to our model and we need to predict. So then from the predicting, we are getting say 0.15. So it is near to 0 and less than say 0.5. So for that reason, our predicted class will, okay. So for 0th, I have mentioned it is a glaucoma. Okay. So near to 0 value, it is glaucoma. So our class is predicting as a glaucoma. Okay. So this code also anyone needs, I will share with you. You can like try to understand, or if there is a if you are, it is hard to understand, you just drop an email. We can communicate. Okay. And for the running and for the data set also, you can download from online. I can give the link, or I will share this data set as well. Okay, then thank you everyone. Anyone having any question?
Thank you, sir. Thank you very much. Now, the participants can come up with your questions if you have any query. Participants? No questions? Thank you, sir. Thank you very much.
Okay, thank you everyone.
Thank
Bye.